Okay, this is the cosine of a sum. In the end, it's the cosine of a sum, right? The sum, right, is two inverse functions, but it's still a sum. So you're still going to use that same formula, right? The cosine of a sum is the cosine of u sine of v. Oh, that was wrong. That was wrong. Cosine of u, cosine of v. It's a sum, so it's minus cosine of b minus sine u sine v. Okay, but in this case, the u is this and the v is that. So that's the cosine of the arctan of 1 times the cosine of the arc cosine of x minus the sine of the arctan of 1 and the sine of arc cosine of x. Then we deal with each one at the same time, right? Remember how we can read this. It's like saying, what is the cosine when the tangent equals 1? Well, on the unit circle, where is it that the tangent equals 1? Remember, for inverses, we're only looking in these two. So where is it that the tangent equals 1? Meaning that the sine equals the cosine? 45 degrees, okay? So what is the cosine when the tangent equals 1? Root 2 over 2. Root 2 over 2, right? So this thing here will be root 2 over 2. Okay, here's the composition of a function and its own inverse. They cancel each other out. All you get is x. Right? Okay, what is the sine when the tangent equals 1? Root 2 over 2. It's that same place that we found this one. We find that one. So it's minus root 2 over 2. And then the last part is a little harder, but we did it in the last chapter, right? What is the sine when the cosine equals x? Well, if the cosine equals x, then that would mean the adjacent is x and the hypotenuse is 1, x over 1. Okay, then I would need to find the missing side with Pythagorean theorem. Square root of 1 minus x squared. What's that? Where'd the 1 go? The square root of 1 minus x squared, right? 1 squared minus x squared, square root. Okay, so now what is the sine? Sine would be opposite over hypotenuse. So the square root of 1 minus x squared.